So we'll start with the prime factorization. Remember, when we're doing the prime factorization, we're going to write our answer two different ways, and they're both good in different ways. One of them is sometimes shorter. The other one will be very useful when we're doing stuff with simplifying square roots. So we'll talk about why we'll use each of them as we need them. Who can help me factor the 81? Maybe 9 times 9? All right. And then each of those 9s, we can factor those still, right?
Yes.
What are those going to be? 3 times 3. And then what about those 3s? Can we factor those? Should we do like 3 times 1? Why not? Since the 3 is prime, if we did 3 and 1, we could just keep doing that forever, right? So we could just keep doing 3 and 1, 3 and 1, 3 and 1, and that would never end. So once we get to a number where the only thing we can factor it is that number and 1, then we're done. That's a prime number. We'll circle it. All right. So the standard form for this is going to be what? Okay, and make sure we get all of them. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, we're good. So it's 3 times 3 times 3 times 3. The exponential form here is a little bit quicker, isn't it? What's that going to be? 3 to the 4th power, and that's all you have to write for the exponential form. All right, how about the 600? How's that 600 going to factor? Okay, so there's a couple of ways that I might do this one. If I were doing it, if you notice that it ends in 2 zeros, you know that 100 goes into it, so you could do 6 and 100. Did anybody do it a different way? Okay, so 60 and 10 would be another good one, so you could do 60 and 10 like that. Either way is going to give you the same answer in the end. So let's go ahead and do the 6 and 100. If you did 60 and 10, that's fine. You could have done 2 and 300, or you could have done 3 and 200, or you could have done 20 and 30, I think. There's lots of different ways you could do this. As long as you do it right, you're going to get the same answer. All right, how about that 6? 2 times 3. How about the 100? Okay, we could do 2 and 50. That's probably not what I would do, but I'll go ahead and do that. So we've got 2 and 50. What's another way of doing 100? 10 and 10 would work also, right? Let's keep going with the 50. Somebody help me with the 50. How does that factor? 5 and 10, okay. 5 is prime. We can keep going with the 10. 10 would be 2 and 5. All right, so now we're going to write out our standard form here. So we need to make sure we go least to greatest and make sure we get all of them. So we have some 2's, right? How many 2's do we have? 3 of them, okay. So 2 times 2 times 2. Then do we have any 3's? Yeah, we've got 1 3 right here, so times 3. And then we should never have 4's, right? So we don't have to look for those. How about 5's? Got 2 of those. Okay, and then how about the exponential form? Okay, so another way of reading this, we could read 2 to the 3rd power times 3 times 5 squared, or we could say 2 cubed times 3 times 5 squared. Okay, remember, cubed is to the 3rd power, squared is to the 2nd power. And if we wanted to, we could put an exponent on the 3. Since this is exponential form, what exponent would go on there? That would be a 1 if you want to put it there. Okay, remember, with exponential form, you don't have to have the exponent when there's only one of them. But if you want to, you can put the 1 there. So then with these, we want to evaluate these square roots here. The first thing I want to do to evaluate any square root is to get a square on the inside, to write it as a square. So instead of 64 in the radicand, I want what to be in the radicand? 8 squared, right? So 64 is the same thing as 8 squared. Now, a lot of people forget to put the square root on here. We haven't done anything yet to get rid of the square root. Okay, we just changed the 64 to 8 squared, but the square root is still going to be there. So we need to make sure that we keep that square root until we cancel it out. We have to keep the square root until it cancels. Another thing I want to do just to keep my work neat and organize is to put an equal sign here to show that this square root of 64 is the same thing as the square root of 8 squared. Now that we have a square inside of our square root, what can we do with them? We can cancel them out. The square and the square root are going to cancel each other out, and that's going to leave just what? Just the 8 that was on the inside. Okay, this next one, we already have squares inside of the square root, so we don't have to write it as a square. We can start by doing what? We can start by canceling right away. So the square root is going to cancel out this square right here on the 7. It's also going to cancel out the square on the 11. So the square root is canceling both of these squares, so all of those things are gone. The square root's gone, the square is gone, and this square is gone. So what's left? The 7 and the 11. And remember, we're multiplying them together. We've got the multiplication dot here. So 7 times 11 is? How about this next one? There's a couple of different ways we could do it. The long way would be to multiply 5 times 5 times 7 times 7 and get an answer, and then try to figure out what we square to get that. But there's an easier way. What can we do? Yeah, exactly. So that right there, that's the same thing as 5 squared, and that right there is the same thing as 7 squared. So we can rewrite this as the square root of 5 squared times 7 squared. And now this looks just like the problem before, where we have two squares being multiplied together. Okay, this is going to make it a lot easier because now we don't have to multiply it out and get a really big number and then figure out what we square to get that really big number. Okay, you don't need to do this part down here, this part that I wrote in. I was just showing you where the 5 squared and the 7 squared come from. Now that we have those, what can we do? Cancel the square root with both of those squares. So the square root's gone, the squares are gone, and that leaves the 5 and the 7, and 5 times 7 is 35.